Yeah, good afternoon, ladies and gentlemen. My name is Walter Weigel, and I'm the Vice President of the Huawei European Research Institute. Let me shortly introduce. The name is a little bit misleading because actually it's not one institute. It is our research organization here in Europe, and it comprises 18 sites in 8 countries, and currently we are about 1,400 researchers. And I wanted to talk to you shortly about our research linked to 5G and the Internet of Things. And just to warn you, I will certainly give a short insight in what I think about 5G radio. But on the other hand, I think we all together in the community are doing a little bit of mistake because we concentrate so much on radio only, and 5G for the IoT is a little bit more, and I want to show you. Now, you all know that we are discussing currently what does the parameters, the requirements for 5G mean. And we have really to throw the stone significantly further compared to 4G. So one of the very important topics is when you think about augmented reality, smart manufacturing, connected car, the different applications where we will have 5G technology in the future related to vertical industry, Internet of Things applications. The latency, real-time behavior, very, very important. And when you want to have an end-to-end real-time latency of 10 milliseconds, then we believe you have to be on the radio at 1 millisecond. You all know we are talking about mobile broadband, which is one of the big directions for our 3D displays on the smartphones, for instance, in the future. We are thinking about 10 gigabit per second per connection. We may even go up to 20, 30, 40. But then one of the big questions is at which carrier frequency. And I personally believe we will need a set of frequencies because to go into these high data rates, you can easily do it with millimeter waves, but then the cells get very small and you have big challenges in the mobility management in the network. I will come back on this. On the other hand, if you want to do it for wearables, for instance, or for smart health medicaments, you may need a penetration. If you do it in the cellar of your house on your cycle, then maybe 700 megahertz has a lot of advantage because of the penetration into the houses. Another big topic in IoT, when you think about industry applications in Industry 4.0, or even where I am not in smart farming, will 1,000K connections, sensors, tags per square kilometer be enough? When you think about high-speed trains, we are currently assuming we need to support 500 kilometers per hour high speed, and we want to have a slicing of network architectures. I will come back on this again, a high flexibility in the network. Now, the goal is one network fits all applications with a very high flexibility, and honestly, as we are discussing, and we have started not only to discuss in research together, but we have started now in 3GP with the standardization of 5G radio. Whether this will be one radio technology with a lot of parameters where we can adjust and we will get this flexibility, that's one solution. But maybe we need a set of parameters and technologies. This we will see in the near future. Now about IoT itself, from the history of mainframes over the PCs, the mobiles we have today with thousands of millions, to the cloud. Whoever you ask from consultants, you get very high numbers of the things. So the tags, the sensors, the activators, the readers. We assume currently more than 100 billion of connections. And on the bottom, I have allowed myself to tell you I observe currently there are a lot of greenfields providing connections, but even more for providing revenues. And I think we need certainly technological solutions, otherwise the revenues will stay on the slides and not really happen. Now I want to come back on my initial thinking that the radio is a very important part, but it's not the whole story, because from bottom to top, we need the little hardware, the thing. What does this mean? And maybe you know we have in Huawei a silicon unit, which is high silicon, so we do research on this as well. It's not so well known because we only use the chips for our own products. For instance, for our wireless modules, we do not sell chips. We are not in the semiconductor business. You need the connections now from 4 and 4.5G up to what we are doing in research, the 5G, coming to an agile IoT network. And then what do you do with all the data? Because if you have hundreds of, even billion of sensors, and even if they provide only every few seconds a few kilobit, nevertheless, this amount of data has to be used, explored, so you have to store it somewhere in the famous cloud, and you have to do big data analytics. Now, along this value chain, radio, I talked about the requirements, capacity, 1,000 times as high as in LTE, the speed, the 10 gigabit per second, the latency, I've explained the 1 millisecond, the links per cell, at least 100 times more. And let me come back on two very important topics. One is here on the slide, namely the energy. If the sensors are driven by batteries, I personally do not expect that we will have revolutionary battery technologies giving us a leapfrog in how to provide the energy. So there are two options to reduce the battery consumption, the power consumption, by hardware and also optimizing the hardware with the algorithms which are running on the things. So optimizing hardware and software, where we have a close look in. And then I have another, let's say, self-critical comment from us, the ICT industry. As said, we have started in 3GPP, the discussion on standardization under these requirements. And I think we have to make sure, together with all our colleagues, friends and partners from the vertical industry, that these requirements are the real ones. Because if we, from telecom ICT industry, start here with some wrong parameters, then later on we will have a big issue in rolling out the technology. Now, as I said, the value chain is going further. What about the 5G network? This is a very complicated slide from my colleagues who are doing this research, but in a nutshell, what do I want to tell you here? Currently, you see on the bottom, this is so to say the physical world, and we are discussing about software-defined networks. So in a far future, you may have a standard hardware, and you define by software, is this a router, is this a switch? And then we're coming to network virtualization, the famous slicing. You define in your network, for instance, a private network, and you configure it. I need 10 routers, 15 node Bs, 20 switches, and so on. We are going a step further in research, what we call SDI. This is why here are other levels shown in this chart. So we are talking about software-defined infrastructure. What do we mean? And the essential part is in the middle. You see a SDI, software-defined infrastructure, distributed control plane. And there is an intelligent orchestration. So in these colors, very far up, what we assume is that we not only slice, virtualize the network entities, but that we include really the services. And what is essential? You need resilient, self-healing, especially in the control protocols. You see here RPC or open flow as basis. This is why we are saying here in extensions. And you need the orchestration where you know with the databases on the top left what kind of modules, entities do you have? How is the topology currently dynamically defined. And then by the different applications, this little library, what we call the shared C application library, quality of services, for instance, or shortest path first, how to route through the network. These are then the applications we want to provide. And then, as you see, you get on a very generic level what we call an API. This is the SDI, Software Defined Infrastructure API, where you can really dynamically then configure even the services. So not, how shall I compare it? In a cloud, you have many computers, and finally you can do either real number crunching, or you can use them for a lot of text software. And we are going to this level where you don't care anymore about how the cloud looks like, but you configure the kind of applications. So that's currently going on in our research. Then, as I said, what do you do with all this data? And as you may know, we in Huawei today, we are also providing hardware and software for cloud and big data applications. But we in research, we have a look on two different goals. One is in the cloud, namely that there is a portability so that you can configure different solutions in one cloud, that you have a service level agreement-driven management, so that this is, so to say, flexible, and the cloud itself is hybrid. So for instance, from ourselves, from other providers, and this is a step where we are doing especially a lot of software research, how to manage this. Then on the big data side, because just to store the data, that's not enough, you want to analyze it. Here in research, our goal is we are relying in Huawei on open source software. So currently our products are all Hadoop based. And you can see what we call Fusion Insight. This is in this little top right graph. We are looking in how to improve the analysis of bulk data from the warehouse by real-time analytics, and on top of Storm, Spark, and Flink as a basis, again, open source. We are doing a lot of research how to combine it together. So our goal is that we can offer within 5G an elastic, which means flexible framework for real-time validation of big data. And I think this is very, very important for Internet of Things applications in vertical industries. You cannot wait for a day or even a week until you get your results back. Then any planning time window is over. Now, I have offered in my description of the talk to give you a few examples. And this is now a mixture. You see like this one, real 5G experiments, field trials. My problem is that I have signed NDAs and I cannot tell you in detail what we are doing, but I wanted to give you an idea. This is from Christoph Tümmler. He is a professor for e-health at the Technical University Munich. And when you look just at the figures, he has analyzed about smart medicaments. 150 million inhalers, so for heavy smokers or asthma patients. Think about sensors, wireless modules incorporated. There is a number from China, which is already huge. Then when you think about diabetes patients, they are using their little sticks for balancing out their blood glucose level. Again, if you add sensors and a wireless module, what are the numbers to cover diabetes in Africa 2035? 100 million connections. Southeast Asia, same time frame, 250 million connections. Middle East, Northern Africa, same time frame, 120. And in the Western Pacific region, by 2035, altogether 400 million. And so one of the solutions is to have these smart medicaments connected via 5G. By the way, I am asked frequently, Walter, that's very simple. We can connect it today over the Bluetooth to the smartphone. That's true. but can you really rely on a patient who is seriously sick to always deal with the smartphone to make sure it's charged, the battery is full? In many hospitals in Europe, you are not allowed to use your smartphone. So I think there is a big step forward if we can connect them directly to a network via 5G. That's one of the research we are working on. Now, I said it's a little bit a mixture. This is actually 4G, but it gives you a flavor. The background, this is a Chinese client where we have provided a solution from Huawei together with our colleagues from SAP. This is Zoomlion, the biggest heavy machinery, construction machinery company in China. And this is about predictive maintenance, but it's a real case. So originally, before we came up with a sensor data collection and then hence using this data, the fault analysis and then the predictive maintenance. By the way, you see our value chain here from access router, access points, and N9000 is our storage system for big data, where we can offer really as a product up to 40 petabytes. So should be enough for all the use cases I've seen so far. And what have we reached? That the fault time was, before the solution was introduced, 30 minutes per month. And we are down for the customer to 6 minutes per month. And so the fault time reduced by 80%, the fault ratio by 70%. Now back to real research. This is where we are working with partners on the connectivity for autonomous driving. Don't read all this. It's really from one of our scientific presentations, but I wanted to give you a little bit an idea, what do we do hands-on? What does this research mean? And I just want to introduce the 3 different cases because you may say, okay, autonomous vehicle, all the OEMs, the car manufacturers, they have a lot of sensors and cameras in, and the car will be by itself autonomous. That's true. But for instance, if you have very dense traffic, if you cannot look around the corner whether a car is approaching a crossing, or if you want to use better the infrastructure, for instance by trucks, lorries, where the distance from one to the other is mainly only 1 meter to have a much higher usage density of our motorways, then it's getting tricky with sensors only. Now this is where we are coming into the game, and we are looking into the wireless connectivity, and you have here 3 different cases. The left one is relatively simple. You have an in coverage in a mobile network, cellular network, like for instance 3GPP, in the future then 5G. I go to the very right, that's the contrary. The cars are out of coverage. Because in the first one, you see the yellow lines, you may assume, okay, I do everything just over the network, over the base station, the node B. The right case, okay, I do the other extreme, I do just vehicle-to-vehicle communication, car-to-car communication, and I don't care about the infrastructure network. But in most of the cases, you will have a mixture of both of them, and this is the one in the middle. And then the question is exactly, how can you make the best use out of the 3 different sources, sensors, cameras, autonomous, the right one, plus vehicle-to-vehicle communication, plus cellular. And for instance, one of the ideas we are doing research on is how to combine, you see the yellow line in the middle, also there is cellular reception, but if it's very critical, there's a car coming where you cannot see from right-hand side into the crossing with high speed, may not brake. And you need really within a few milliseconds this information to brake your automated driving car. Then it may be very good to have a combination, so to do the control over the network, over the node B, but to have the real data exchange, the user plane over car to car. So this kind of research gives you an idea of what we are currently doing, and you see, besides the description, also the different challenges. Now back to a real case, but which gives us requirements for the 5G research. PCITC, you may not know, this is a daughter company of Sinopec, the China petroleum and chemical industry company. And we are here working together with our customer. What have we done? You see a picture of a refinery. And there was, before the project, a data collection, automated, of about 74% of all the data. Now, this leads to one issue. If something is going wrong, you have, so to say, a black hole of 26%, and you have to send people in. So, human safety exposure, HSI, and there may be a risk. And actually what we have done is we have increased the data collection automatically to 95%, and this has reduced the exposure time for the human workers, for the personnel, for the staff, down to 20%. And as you see again from our side, we provided the whole infrastructure, taking up the sensor data, access routers. We are using here eLTE, and again, the data is stored in our data center. Now, coming back, where I said we have to be a little bit self-critical in the ICT industry, this is standardization. I think it's clear. We are talking here about communication, and this should be global standards. We should not have here fragmented geographical single standards. There are for sure a lot of industry alliances, like IIC, many of you know, right bottom. But on the other hand, I wanted to show this slide from my standardization colleagues on the different levels, from applications over platforms down to the IoT, the thing itself. There are a lot of activities going on. You see here with the white text where we from Huawei are quite active. But again, my warning is a little bit, and I'm pushing within our company and together in our research, together with the standardization colleagues, we should not do the mistake only to concentrate on what we, ICT industry, are used to. Because otherwise, we may fail to include all our colleagues and partners from the vertical industry. And so I'm also advocating IEEE is relatively broad, W3C is doing a lot of attempts to broaden the scope. And what is not yet on is many of the vertical specific organizations like Car-to-Car Communication Consortium, to give you one example. But I think urgently we have to work closer together. And this brings me already to the end of my presentation, and with a nice picture from the communication colleagues I've stolen. If these fish are all the sensors and the things of the IoT, these 100 billion we want somehow to catch, my offer would be the following. We do have 2 research centers in Europe. One is the 5G Innovation Center. This is the mobile broadband, more focusing on the smartphones and what they need for 3D or holographic displays in the future. This is what we're doing with the University of Surrey, and you see here several of our partners. And I wanted more to make you aware of what we are doing in Munich. We do have real 5G infrastructure. For sure, the modules are not this small, they are like this, but they are really mobile, we can transport them. We do have test licenses by the German regulator, and you have seen some under NDA activities going on, but if you have a good idea, if you think there is a value in doing research with us, in using 5G technology along the value chain I've shown to you, please feel free, contact me, and we may have another field trial in Munich. With this, I would like to conclude my talk, and do you have any question? If so, please feel free. Okay, if this is not the case, thank you very much again for listening, and have a nice afternoon.